Okay, hey, hello everyone. So, did you enjoy the video? If you do, okay, that is very fine because I also watch wrestling regularly. And if you didn't enjoy that, I'm so sorry because what you are going to learn right now, maybe you won't enjoy it again. Okay, so in the first video, that white-haired person known as Brock Lesnar is thought to be a chemical system, and the championship belt and his championship belt is an electron. Imagine it in that way. And the long black-haired guy called Roman Reigns is another chemical system. Let's call Roman Reigns chemical system A, and that white guy with the championship belt, that means the electron, as the chemical system B. Okay, so what happened is that the long-haired guy, whose name is Roman Reigns, has snatched the championship belt, that means the electron, from that from Brock Lesnar, isn't it? Okay, so we will try to explain it in terms of, or we will try to imagine the video in terms of what we are calling it as the electrode potential. Okay, so what is electrode potential? So electrode potential, this is the value that indicates the ability of gaining electrons. We must focus on this point. Okay, so electrode potential is the ability of gaining electrons. Okay, it's only gaining. Okay, only gaining. Okay, so here that long-haired guy, the Roman Reigns, had a greater electrode potential or greater ability, and that short-haired guy, short white-haired, the Brock Lesnar with the championship belt, has a lower electrode potential value. Okay, so what happened? What happened there? The Roman Reigns has snatched the championship belt, that means has gained the championship belt, that means the electron, from Brock Lesnar. Okay. Okay, so after listening to this part, you may go back to the video and watch it again and try to imagine. Okay. Now let's go into our lesson. Okay, so look, so the higher the electrode potential, the higher is the ability to gain the electron. Okay, so electrode potential is nothing, it is just experimental measurement of how strong is a chemical system in terms of gaining electron. If the system is strong enough, or it's very strong to gain an electron, so its electrode potential value is mathematically higher. Okay, and these are all voltage values. These are all some sort of voltage values. Okay. So now how will we measure the electrode potential? Okay. So the values of electrode potential are measured in comparison with hydrogen. Okay. That means all electrode potential values are measured by connecting a chemical system with hydrogen. For example, if you want to measure the electrode potential of sodium, then you have to connect it with a voltmeter to hydrogen. Okay. So what will happen? And we guess that if we are measuring the electrode potential of this sodium, so we would expect, or we would think, that sodium will gain electron from hydrogen and would show us a voltage which we would call the electrode potential of sodium. Okay. Now, if you want to measure the electrode potential or electron gaining capacity of chlorine, then you have to connect chlorine through a voltmeter to hydrogen. Okay. So we would expect that chlorine would gain electron from hydrogen and show us a voltage that would be the electrode potential of chlorine. Okay. This is how we measure the electrode potential, and the higher the value of electrode potential, the higher is the electron gaining capacity. Okay. Now, let us look here. Look, this 0.34 value is the electrode potential of copper, and this value minus 2.71 is the electrode potential of sodium. So, mathematically tell me which one is greater. Is it 0.34 or minus 2.71? Which one is greater? Obviously, 0.34 is greater and minus 2.71 is smaller. That means the electrode potential of copper is greater and electrode potential of sodium is smaller. Okay. So, which one has the higher electron gaining capacity? Obviously, copper, because the electrode potential value of copper is 0.34. And how is the value 0.34 obtained once again? Okay, so this is a copper system, this is a voltmeter, this is a hydrogen system. So, copper is connected electrically to hydrogen through a voltmeter, and we have guessed that electron has flown from hydrogen to copper. So, here we have obtained the voltage value of plus 0.34. Okay. Okay, all right. So, in this case, now what will happen? Just imagine that you are connecting a copper system through a voltmeter and then to a sodium system. So, what will happen? Copper has the value of positive 0.34, sodium has the value of minus 2.71. So, what will happen? So, obviously, here copper will gain the electron. That means, copper is the reduction half cell. Since copper is gaining the electron, and gaining electron means reduction. So, copper is the reduction half of the whole system, or reduction half cell, and sodium is therefore losing the electron, and losing electron means oxidation. So, sodium is called the oxidation half or oxidation half cell of the whole electrical system. Okay. So, using the electrode potential values, you can easily predict that who will get oxidized and who will get reduced. Okay. Okay, so copper has the value of positive 0.34. All right. So, copper has the value of positive 0.34. This does not always mean that copper always has a greater power of gaining electrons. Okay. Look at the electrode potential value of silver, it is 0.80. So, if a copper system is connected with if a copper system is connected through a voltmeter with a silver system, and look, the electrode potential value of silver is higher. So, silver is going to gain the electron here. Okay. Silver is going to gain the electron from here, and therefore, copper would have to lose it. Okay. So, a certain chemical system might be oxidized or might be reduced based on who is connected with it or what is connected with it. Okay. So, therefore, when you are writing the electrode equation of a certain chemical system, you have to write both the oxidized part and the reduced part. Okay. Okay, let us look at this equation. So, when you are going from when you are going from copper 2 plus to copper, that means you are gaining electron, that means this is the reduction. Okay. So, the forward reaction is a reduction and backward reaction is therefore the oxidation, because here copper is converted to copper 2 plus, here it is copper 0. Just remember from your AS level study that these values are called the oxidation numbers. You remember? Okay. And if the oxidation number increases, then we if the oxidation number decreases, like from copper 2 plus to copper 0, we call it reduction. So that's why this is the reduction. And when oxidation number decreases, increases, that means from 0 to 2 plus, then we call it oxidation. So that's why the backward reaction is the oxidation. All right. Okay. So this is formed after reduction. So we call it the reduced form, and this one is formed due to oxidation. So, or this one would be formed due to oxidation. So we call it the oxidized form or oxidation form. Okay. So the rule of writing the equation, the electrode equation, is that it must include both the oxidized form of the chemical system and the reduced part of the chemical system, and reduced form has to be in the product side always. Okay. Reduced form has to be in the product side always. You might like this reproduct. Okay. Reproduct, which means reduced form is always in the product side. Okay. Okay. So you don't need to bother about the electrode potential equations. All the electrode potential equations will be given in the data booklet. Here I give you the part of your course book, but more diversified part will be given in the data booklet. All right, no problem. Okay, so and you must put a reversible sign between the oxidized part and the reduced part, because the reaction might go in any direction. Okay, so you must put a reversible sign here. Okay, so here the electrode potential values, some electrode potential values are given. Okay, so now let's go to our next content, the cell potential. Now what is cell potential? Okay, first try to remember what is electrode potential. So electrode potential is the voltage of a chemical system. I'm writing silver. It's the voltage of a chemical system when the chemical system is connected electrically with hydrogens. Okay. So this is the voltage you will gain here is the electrode potential, symbolized as this. This is the or known as the standard electrode potential. But if two chemical systems are connected, okay, by a voltmeter, and none of them is hydrogen, then the voltage you will get is known as the cell potential. Cell potential of the of that whole chemical system. Mention the name. Cell potential of silver copper system. Okay. Okay. Now how to calculate the cell potential from the electrode potential? Look at this formula. Cell potential is equals to the electrode potential of the system being reduced and the electrode potential of the system being oxidized. Remember that when two systems are connected based on their electrode potential values, the one having the higher electrode potential value will be reduced and the one having the lower electrode potential value will be oxidized. Okay. Here the example of chlorine copper system is given. Okay. I will show you an example. For example, let me take two random system from here. Okay. Okay, so I start from here. So this is the Na. হবেই বলছি না হতেও তো পারে। Okay, so this is the end here. Okay, and I take two random systems. Look here, this system is the how you will write. Uh, so you will always write from the from the right side of the equation to the left side. Okay, so you would say that this is the CR207 CR3 plus system. Okay, why I have chosen this two? Because here look, the chromium is the element whose oxidation numbers are changing, so we should always include those parts only whose oxidation numbers are changing. Okay, okay, and here you just remember that oxidation number of H plus or H doesn't change. So here I will prefer writing this one and this one. Okay, so we will call it as H2O2 H2O system. Or if you are confused about writing the nature of a about writing the identity of a system, just remember that in except hydrogen system, then you should omit hydrogen ions, electrons, and possibly water from any system. Oh, okay, okay, no, this is not going to work very well. Okay, just what I have said, just try to remember that. Okay, so just the part whose oxidation numbers are changing. Okay, like here chromium Cr207 and Cr3 plus, the oxidation numbers are changing. Okay, so I had chosen this one and this one. Okay, so here the chromium has got an electrode potential value of plus 1.33. H2O2 has got an electrode potential value of 1.77. So this electrode potential value right here is greater, and this electrode potential value right here is smaller. So when we would connect this system with this system, then this system is going to get reduced, that means gain the electron, and this system by force is going to get oxidized, because it's not possible that at the same time two system gets reduced and two system gets oxidized. It's not possible. So if one system gets oxidized, or if one system gets reduced, then the other system has to be oxidized. All right, okay. So what will happen is that in this reaction, in this case, the reaction would go from this side to this side. It will be reduced, and here the reaction would go in the opposite side. Okay, because this is going to be oxidized. Okay, by force. So what would be the E cell value of these two systems? This would be plus 1.77, because this system is going to get reduced, minus plus 1.33. Okay, so what would be our value? Our value would be 0.44 volt. That means if you connect these two systems, then you would get a supply of 0.44 volt. Okay, okay. And just remember one more thing, that the system which is getting reduced is what we call the positive side, because you can imagine it in this way, that this system is gaining electron because it's positive, and the system which is getting oxidized, that means losing electrons, is what we call the negative side. You can imagine it in this way, that since this is negative, so a lot of excess electrons are here, so it is losing the electrons. Okay, so the system which is reduced is positive, and the system which is oxidized is the negative. Okay. Okay, so let's zoom out. So this is how the cell potential. Now the cell potential, okay, this equation can also be used. Look at this statement. This equation can also be used to choose oxidizing and reducing agent for a reaction. Okay, before going into details of that, we must focus on this slide, the electrochemistry rules. Okay, so if the voltage values, there are some rules like positive voltage, there can be positive voltage values and negative voltage values. Look here in this column, here are two negative voltage values, positive voltage values, negative, 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 positive, positive. All right, so the voltage values can be positive or negative. So what does the positive values indicate? The positive values indicate that what the reality is the same as that you have predicted, and the negative voltage values indicate what? the the reality would be the opposite of what you have predicted. Okay, now let's go into the some slight details. For example, let me tell you one thing, that I predict that fluorine system would reduce chlorine system. Okay, so fluorine system would reduce the chlorine system. That means chlorine system would get reduced by fluorine, and therefore fluorine will get oxidized. Okay, but is this really going to happen? Let's see. Let's calculate the E cell value, since these two are the systems, none of them is hydrogen. So E cell values of fluorine system is, no, it's electrode potential of the reduction side minus the oxidation side. So this chlorine system is going to get reduced. So first positive 1.36 minus electrode potential of the system being oxidized, which is the fluorine, plus 2.87. Okay, now this value is going to be negative, isn't it? So negative 1 5, so negative 1.51. So here a negative value appeared, isn't it? So what we have thought, we expected or we predicted that chlorine is going to get reduced and fluorine is going to get oxidized, but this is actually not going to happen. What is going to happen is that chlorine will get oxidized and fluorine will get reduced. Okay, so here this is what I'm trying to say, that if somewhere the voltage values appear to be negative, then the reality is the opposite of prediction, and if the voltage value appears to be positive, then the reality would be the same as the prediction. Okay, now you might think that these, what does this negative values indicate here? Okay, these negative values indicate that although we have predicted that the system would gain electron from hydrogen, but this is not actually happening here. What's actually happening is that the system is giving electron to hydrogen. It is not gaining electron from hydrogen. But remember, we will always consider the gaining ability. Okay, because we must have one reference, either gain or lose. So we are considering the reference as gain. Okay. Okay, so this equation can also, this electrode equation can also be used to choose oxidizing and reducing agent. Okay, let's go back to that table again. Now I'm telling you, you have to choose. I am considering magnesium system. Okay, So you have to choose a system, or you have to choose a chemical system that is going to reduce this magnesium. Okay, that has the ability to reduce the magnesium. Okay, so let's consider E cell. Okay, no, first let's do it logically. So magnesium has to get reduced. That means its electrode potential value has to be higher than the electrode potential value of anything. So what do you say? What do you say? What do you say? Okay, if I tell you calcium, look, the calcium has the value of minus 2.87, whereas magnesium has the value of minus 2.38. So which one is greater? Obviously minus 2.38 is greater. So if the calcium system is connected to magnesium system, if the calcium system is connected to magnesium system, then magnesium having the higher value will get reduced and calcium will get oxidized. Okay. Now let's see that whether we are correct or wrong. E cell is equal to, or if you have difficulty understanding it logically, you might do it mathematically. Like magnesium has to get reduced. Okay, so E cell is that, you know, that electric potential of the reduction side minus electric potential of the oxidation side. So put the value of magnesium around here, which is minus 2.38. Okay, minus. Now you have to put a value here so that the E cell value would appear to be positive, because, you know, if the value appears to be positive, then the reality would be what you have expected. Okay, so if you put the value minus plus 2.87, then this would not work, because the value would overall value would be negative. Okay, so this would not work. Now if you put this value minus 2.87, then this E cell value is going to get positive, isn't it? So it would be 9, 4, positive 0.49. Okay, so the value is positive. That means what we want is going to happen. We wanted the reduction of magnesium, so we have put the electrode potential value of magnesium in the reduction corner, and here the electrode potential value of calcium in the oxidation corner. Okay, so our value appears to be positive. That means magnesium is going to get reduced by calcium. Okay, so this is how you can choose the oxidizing agents and reducing agents. Okay. Okay, now if I tell you to choose if I tell you to choose a value or a chemical system that is going to oxidize the chromium. So oxidize the chromium. So chromium is not going to get reduced, it is going to get oxidized. So another system is going to get reduced. So that another system must have a higher electrode potential value than this chromium system. So now go for finding a value which is higher than 1.33. So it can be 1.36, it can be 2.87, isn't it? It can be 1.77. So all these systems, this system or this system is going to oxidize this chromium system. Okay, and you can also do it from the electrode potential. You can also prefer doing it from the cell potential system. So write E cell, you know, E cell equals to, okay, you can write it here, you know, E cell equals to the electrode potential of the system being reduced minus electrode potential of the system being oxidized. So you have to oxidize the chromium system. So put the value of chromium over here, the oxidation corner, and try putting a value here so that the overall E cell value will be positive. All right. Okay. So the summary, if a system is connected to hydrogen, then we call it the electrode potential of that system, and if two different systems are connected, then we call it the cell potential. Okay. Okay, now this statement is very important, that when electrode potential value is measured, I am repeating it again, electrode potential value is the electron gaining ability of a system. So when electrode potential values are measured, we must predict or expect that the system is going to gain electron, that means it is going to get reduced. So that is a reference. Okay. Now we will determine changes in the electrode potential values. Okay, look, the values given here in this table are all the standard electrode potential values, isn't it? Look, it is already written here. So these values are the standard electrode potential values. Now what do you mean by standard? That means all these values are calculated by connecting the system with hydrogen at 25 degrees Celsius or 298 Kelvin, and at a pressure of 1 atmosphere, and all the aqueous solutions having concentrations of 1 mole per tm cube. Okay, so these are the three conditions that were maintained while calculating all these electrode potential values. Okay, all right. So if there is a change in these conditions, then the electrode potential value is really going to change. How? Let's see. In case of chromium, you remember that rule highway. Let me write it for you. Highway. Oops, I don't like the color. Highway. Okay, highway actually stands for that if you use a high concentration, then the reaction is going to get away from it. If you increase the concentration of something, the react or make the concentration high, the reaction is going to get away. What does this actually mean is that, for example, if you increase or make the concentration of this chromium dichromate high, then the reaction is going to get away from it. Okay, and conversely speaking, if you make the concentration of this dichromate low, so the reaction is going to get towards it. So at high concentration the reaction goes away, at low concentration the reaction goes towards. Okay, remember this. Let me show it over here. If you increase the concentration of Cr3 plus, that means high concentration, so the reaction is going to get away from it, and at low concentration, if you reduce the concentration of this chromium, then the reaction is going to get towards it. Okay, so high concentration reaction goes away, and low concentration the reaction goes towards. Okay, now what does this have to do here? Okay, so if you increase the concentration of chromium, or if you increase the concentration of H plus, then what's going to happen? The reaction is going to get away, isn't it? So you know that reproduct, you remember reproduct reproduct means the reduced form is in the product side. So this is the product side, this is the reactant side. So this side contains the reduced form and this side contains the oxidized form. So when you are going from reactant side to product side, that means you are doing reduction. So if this is increased, then reaction is going to get away from it. That means there is more reduction. Okay, and as you know that we have predicted a reduction when we are talking about electrode potential values. Electrode potential values are the gaining ability, that means the ability of a reduction, isn't it? So if more reduction is occurring, then the electrode potential value is going to get more higher. Okay, now imagine what would happen if you reduce the concentration of this. Okay, so when concentration is reduced, the reaction goes towards, that means from the left side or from the product side to the reactant side. Okay, so from the reduction side to the oxidation side, that means more oxidation is occurring. More oxidation means there is less reduction or less electron gaining, so the electrode potential value is going to get less. Okay, we will always speak in terms of reduction. Okay, but these are all qualitative discussions. We really need to go for quantitative discussions. I would request you to pause this video and read this paragraph.